In a world too small to see, silent forces shape everything we know. From the surface of water to the way we breathe, they are invisible architects of matter. These are intermolecular forces, subtle attractions that pull molecules together, hold liquids in drops, and allow solids to form structure. At their weakest, these forces appear as van der Waals interactions, fleeting, momentary dipoles that arise when electron clouds waver. Weak alone, but powerful in numbers, like whispers that build into a chorus. In polar molecules, opposites attract. Dipole-dipole forces form when positive and negative ends find alignment, an elegant dance of molecular symmetry. Then comes hydrogen bonding, stronger, more specific. Between water molecules, it holds oceans together. In DNA, it holds life's blueprint intact. Though invisible, these forces govern the texture of clouds, the surface of skin, the cohesion of blood. They are the reason water beads, the reason some creatures can walk on walls. Intermolecular forces explain why oil and water repel, how trees pull water upward, how your lungs expand with breath. They define the boundaries between one substance and another. What we see as chemistry is often the gentle pull of molecules in balance, attraction without bonds, power without permanence. In the stillness between atoms lies the structure of everything. These are the forces that hold the world together.